Okay, all right. Thank you, Sahana. Welcome everyone to session 6 of ISTQB training CTFL. And today, first of all, we will go through a recap of what we did in the last session. So in last session, we covered our SDLC models. We completed that section, and we also started test levels. So we went through that, what are test levels, what are the attributes of test levels, and then within test levels, we covered component testing, which was the first test level. So in today's session, we will continue with test levels, with further test levels, and we will cover integration testing today. So just for our reference, I have integrated this slide again from the previous one so that we can see that what we covered. We did component testing, and today we will cover integration testing, and then after that it will be system and acceptance in the further sessions. Right. Okay. So I hope that everyone is now familiar with component testing concept completely, and there are no confusions, because that's really important in order to proceed with the further test levels. So in component testing, the focus was more on components, individual components, which can be smaller units, which can be tested individually. Now coming to integration testing, it focuses on interaction between components or systems. So over here, there can be one system which has multiple components, and integration testing can be performed on how the components are integrating with each other, interacting with each other, or if there are multiple systems and we are performing integration testing on multiple systems. So we will cover that in detail as well. So I have taken an example over here so that in our rest of the session, we can, wherever needed, we can refer to this example, and it will be easier for us to understand all the concepts. So we have taken an online library system where we assume that there's a membership system where you maybe you have gone to the library and you have got your membership card, and then they give you access to an online library system as well, where you have to log in, and after login, then you have all these the different features accessible. So you can manage your account, you can search for a book or any magazine, or maybe any CDs, etc., video content. You can also reserve any material, or you can renew any of your existing book, and you can also provide some feedbacks. So this is a very simple online library system. Right. Okay, so in integration testing, there are further two levels. So we have component integration testing and we have system integration testing. As we already saw in the definition of integration testing, that it focuses on interaction between components or systems. So that's why it's really important that we further split it into these two different types of testings. So let's go through component integration testing first. So this testing focuses on the interaction and interfaces between integrated components. So as I already mentioned, that if we have multiple components in a system, in a software, then if we are taking at least two components, two or more components, then we can perform integration testing between them. But at least there should be two components available. And now let's see that when we perform component integration testing, it's performed after component testing. So once we perform component testing, if there are, let's say, three components, component A, B, and C, and then we move to integration testing and we are performing component integration testing, then we will perform testing, component integration testing between either module A and B, or maybe all three at once as well. So that will be component integration testing. Another point in this integration testing is that it's usually part of the continuous integration process. Okay, so I hope that most of you are familiar with this terminology of continuous integration. If not, then just to give you a brief overview, continuous integration is also known as CI, and it's basically an iterative process. So it's a development practice where developer integrate code into a shared repository, for example, GitHub, etc. So maybe you have heard about GitHub, and there are other repositories as well, like Bitbucket, etc. So the way it works is that, let's say that we have module A and B, and that's the component integration testing is being done. It's successfully passed. Then all the shared code, we just move it into a shared repository. Then later on, when we integrate that system with module C and it's passed, then again we move it to our shared repository. So in our repository, then slowly all the modules are stacking up over there. And of course, when we are merging it to the repository, if there are any issues, then we get to know right away. So we can confidently say that the code which we have in our shared repository is working because we have tested it before. Right. You don't need to know a lot of details about continuous integration at this point. I'm just telling so that, like, if you are not familiar with the concept, then it doesn't bother you. Okay, coming back to system integration testing. So system integration testing focus on the interactions and interfaces between systems, packages, and microservices. Okay, so now over here, there can be multiple systems. So one system can be interacting with another system in order to complete an entire software. And for that, we will perform system integration testing. Then there can be packages as well. So what are packages? Packages are basically nothing else but just set of interfaces. And in layout terms, we can say that they are just like folders. So in our computer, when we create different folders to organize things in a better way, so packages are just like folders. When then coming to microservices. So microservices is like basically set of small services which has its own process, and it can be deployed independently. Right. So now let's see that when we are performing system integration testing. So component integration testing is performed after component testing, while system integration testing is performed after system testing. Okay, I think there is a question. What is meaning of respiratory here? Umair, I'm not sure if I'm understanding your question. Are you sure you wanted to ask respiratory and not something else? No, it's okay. You can ask. Actually, I couldn't understand your question. So if you can please elaborate a little bit more, and yeah, we can go through it. Okay, all right. So Umair is saying he will ask later. It's fine. Okay, so yeah, do let us know at the end or before that if still something is not clear. Okay, so under system integration testing, we also see another point: interactions with interfaces provided by external organization. All right, so system integration testing can be between multiple systems within an organization, which, like, let's say one company is building two different systems, and at some point they have to integrate. So they are doing system integration testing. Another scenario can be that that company is also integrating part of the system which is built by an external company, like a third party. So we are building something in our company, and then there's one portion of the system of the software which is being developed by another company, and at some point we have to integrated. So that will, at that point also, we will do system integration testing. Okay, then it says may be done after system testing or in parallel with ongoing system activities. Okay, so mostly it's done after system testing, or it also says in parallel with ongoing system test activities, that while we are doing system testing, at that point also, depending on how we are integrating the rest of the system, we can do in parallel as well. Right. Okay. So now on the right hand side, again, I have listed all the attributes of test levels, and we did the same for component testing as well. And now we will go through each attribute for integration testing too. So to start with, we have objectives. Each test level has its own test objective. So first of all, we will see that what are the objectives for integration testing. The first one is reducing risk. So just like in component testing, if we test the interaction between components or systems, we get confidence that they are working well together and it reduces the overall risk. So if you go back and if you see the component testing objective as well, reducing risk is one of the objective in component testing as well. And you will see that most of the objectives might be similar to component testing. Second one, verifying whether the functional and non-functional behaviors of the component are as designed and specified. Okay, so we had a similar objective in component testing. The only difference is in that we have over here, we were doing the behaviors of component. Actually, I have done a mistake over here. It should be behavior of interfaces over here. So I will fix it later on, and when I will send you the slides, it will be fixed. But over here, yes, it should be interfaces, not components. So in component testing, it's the components behavior which we test, but over here, we test the interfaces. So how the interfaces will be designed, we test the functional and the non-functional aspects of that. Number three, building confidence in the quality of the interfaces. So integration testing, when we perform that, it increases the quality of interfaces. And in result, we get more confident in the quality of that interface. Number four and number five as well, they both can be merged together. That as we also covered in component testing, that when we, if we find all the defects which we should during component testing, then we can prevent the defects to creep into the higher test level, which is the integration testing. The same is applying to integration testing as well, that there are a few type of defects which we should find in integration testing, which we will cover later. And if we are finding them, then of course we are making sure that we are doing integration testing as expected. And we can confidently say that there is a very low risk that the defects will creep to the higher level, which in this case will be system testing. So I hope this part is clear. Okay, so the next one is test bases. So in test bases, what are we covering? We are covering that what are the requirements and what inputs we need for testing. The first one is software and system design. Okay, so software will have multiple components. So of course we do need a software in order to do any integration testing. And similarly, how these components are organized will be mentioned in system design. So first of all, we need a software and system design. So over here, we are covering everything that what kind of inputs we need in order to perform integration testing. The second one is sequence diagrams. So in sequence diagrams, it shows, there's diagrams which shows the sequence in which the interaction happens between modules or interfaces. So it then makes easier to understand and then build accordingly. So we need sequence diagrams as well. Third is interface and communication protocol specification. So in this one, we need to know what kind of interfaces we are using and how they are communicating with each other. And it can be maybe in form of XML, or maybe if we are using any email module, then maybe SMTP, that how it's communicating. So anything where we need to understand that how interfaces are communicating with each other, we need to know all those details so that we can then plan accordingly for integration testing. Next one is use cases. So first, let's see that what is a use case. A use case represents the action that is required to achieve a goal. So over here, if I go back to this one, so over here, we can come up with multiple use cases of this library system. So we can have a use case that once a member logins to the library system, a member can search a book, can manage account, reserve, renew, feedback. So all these features will be accessible to a member after login. So we can have multiple use cases. So for each, so we have an action for each goal which we want to achieve. Next one over here, we have architecture at component or system level. Okay, so it can be in form of a diagram, or it can be maybe a document. Usually they are like diagrams which describe that in terms of architecture, what are you building and how are users interacting with it. So all these information are at the architecture diagram, or they can be in a document as well. Next one is workflows. So workflows and sequence diagrams, sometimes they are mixed as well. That what's the difference between workflows and sequence diagrams. So workflows are basically also known as like flow diagrams. So flow diagrams actually represents the flow of use cases, while sequence diagrams represent the interaction between the objects. And different journeys that are possible in a system will be defined in workflow. Like for example, if we talk about workflow, we can say that a member log into the system and manage the account, or log into the system and can search something in the catalog of library. So these are different. We'll have a different workflow for all these use cases. Okay, the last one in test basis is external interface definitions. So this one applies if we have something like an external built system. For example, we covered over here that in some cases we can have few interfaces which are provided by an external organization. So in that case, what we have to do, make sure is that if we have any such module, then we have proper interface definitions provided by that external organization. Again, we can go back to this example. So in this library system, let's say this feedback is not a built-in module, maybe there is already a system, like feedback system, which is developed by a third party, and we are just literally integrating it with our library system. So in this case, we have built everything over here apart from this feedback, and then this can be integrated with our system. So let's say in order to integrate this feedback module in our system, there might be some APIs. So we need to know the interface definition, that what are the name of those APIs and how they are defined, etc. So all these will be covered in external interface definitions. Before we move to the next attribute, are there any questions? Okay, I'll move to the next one then. The third one is test objects. In this one, we will be covering that what are the objects on which we can perform integration testing. We need something to perform integration on. So the first one is subsystems. So integration of two or more components of a system forms a subsystem. For example, again, the same library system. If manage my account module and search module, they are ready, then we can say that yes, these two form a subsystem, and we can actually start performing integration testing. We don't need to wait until we develop, reserve, renew, or feedback. We have a subsystem already, and we can begin our integration testing. The same is then later on, maybe reserve can be added, and then we have to perform integration testing on all three. So that's how subsystem are defined. So we do need a subsystem, because as we know that for integration testing, at least we need two components or two systems. Second one is databases. So again, in our online library system example, there must be a database at the backend which is being used, where let's say that all the details of members is being stored, and the catalog of whatever is available in the library is stored as well over there. So and there's like much more information must be part of a database which is linked to that system. So databases are also tested as part of component integration testing. Right. Then the next one is infrastructure. So infrastructure will be tested as part of system integration testing, because as we have multiple systems, so we need to establish communication between these systems, and for that we do need an infrastructure. So that's why infrastructure, we need this will be performed only as part of system integration testing. Next one is interfaces. So let's first see that what is an interface. So we keep on talking about interface. So let's just cover the concept of interface. So an interface basically defines that how a component or a system interacts with another component or another system. So by performing integration testing of interfaces, we verify that if these interfaces are working as per the specifications or not. For example, if we go back here and we perform this search function. So the book details, when we search a book, and of course at the back end, there will be a database where we have a catalog of all the books. So the book details might be coming real time from the DB. So like as we are performing this function, so it might be bringing the real time data from the DB, and it might take longer to do that. Or it may be that there is a batch job which run on nightly basis, and the catalogs are updated maybe at a specific time every night. And whenever we are performing the search function, actually the data which is collected from that batch job, from there it's pulling all the data. And maybe if there is a book which is added after the batch job is has run, then maybe that still not be available in the system. So the reason of giving these two aspects of interfaces is that we need to know that how the interface works, how the things behind the interface work, because then based on that we have to perform integration testing. So our strategy for integration testing will vary on how the interfaces are being built. Coming back to test objects, the next one is APIs. So APIs are application programming interface. So an API, it is an interface to a component or a system that defines how other component or system can use it. So it defines what kinds of request can be made. So if you have worked on APIs, then you would be familiar that in APIs we have few request, and for each request then we get a specific response, or there can be like multiple responses as well. So this is all are defined in APIs, and APIs are also tested as part of integration testing. The last one is microservices. So we already covered that, what are microservices earlier. So these services, we know that they can be deployed and maintained as well individually. So how these services interact with each other, that's what is tested in integration testing. So with that, we have also covered the test objects of integration testing. Coming to the next point, which is test defects and failures. So just like each test level has different test objectives and test objects, the same applies to the type of defects as well. And as integration testing further splits into component integration testing and system integration testing, we'll go through the test defects and failures for both of them separately, and few of them they are the same, so we will see those ones as well. So first of all, let's go through the component integration testing, that what kind of defects or failures can be found during this testing. So it can be an incorrect data or missing data or incorrect data encoding. For example, we can say that maybe in the example of our online library system, we have in Manage My Account, let's go back here. Yeah, in Manage My Accounts, we have all member details over here. And then later on, let's say that we are here in the renew module to renew a book, which means that the system do needs the members details in order to renew the book for that member. But over here, maybe there is some data which is not being updated or being retrieved from Manage My Account, which means that maybe the data is incorrect or missing. So this would be like one example of what kind of defect it is. The next one is incorrect sequencing or timing of interface calls. Okay, so over here, there can be an issue in the sequence in which an interface calls other components. So for example, if we need to reserve a book, okay, over here, if we have to reserve a book, first of all, the member needs to log in. So, which means that there is a sequence in which the interface calls different components. So we can't just access and the system and try to reserve the book, because first of all we need to log in. And that's why if there is any such kind of issue, that will be covered under incorrect sequencing or timing of interface calls. The next one is interface mismatch. So in this one, if in one component, let's say if there are multiple components and in one component there is a member ID, let's say in one of the components we have member ID as an optional field. But later on, when we have to renew the book, of course, for that member, we need a member ID. And over here on this page, the member ID field is mandatory. But because we don't have it over here, so this means that there is an interface mismatch between these two components. So when we are designing the multiple different components, different pages, then we need to make sure that the fields which are same on multiple ones, then we don't have these kind of mismatches over there. Okay, so the next one is failures in communication between components. Okay, so I will merge this one with the next one, which is unhandled or improperly handles communication failures between components, because these two are quite linked with each other. Okay, so what does that mean? That due to an issue, if components are not able to communicate with each other, so then of course there will be a failure, and we'll get to know that, and yes, we will go back and see that where that issue is and we will fix that. And similarly, if those failures are not handled properly, then that will be one of the type of defects as well. To give you an example, maybe sometimes you have seen that if you are using a website, then a 404 error comes, or a service error comes as well. So sometimes if you are not able to access a website, so instead of showing 404, that page not found, maybe that error can be, or that failure can be handled properly, and a page can be shown that, oh yeah, we have some mistake, we have some issue, and we are looking into it. So that would be a good user experience rather than seeing a 404 error. Same like if there is a lot of load on the website, and or there is a error which is not handled, and instead of the exception page, we can again show a very decent page in order to just give a good user experience to the user, that oh, okay, we ran into some mistake issue, and we are looking into it, and maybe you can refresh, or maybe you can come back in 5 minutes or so. So that would be a good user experience, and for that we need to handle all the failures, or you can also say handle the exceptions in developer terms. The last one is incorrect assumptions about the meaning, units, or boundaries of the data being passed between components. Okay, so for this one, we can take an example of maybe in few of the registration pages, or where like you have to give your delivery address. So like say if you are buying something online, and where you have to give your delivery address, you must have seen that there are address lookups, where if you enter your postcode, then there is an address lookup which will bring the list of addresses within that postcode, and then you can select one of the address from there, your address from there. So that address lookup is basically an API. So over here we are saying incorrect assumptions about the meaning, units, or boundaries of the data being passed between components. So as in this example which I gave, we are using that address lookup as we are using an API to integrate that address lookup to the page of delivery page. And let's say if we have any issue over there, then in that case, we will have an error, and maybe the user is not able to proceed further with checkout. So in that case, you must have observed that if you're not able to find your address giving your postcode, or if there is any other issue, if for some reason address lookup is not working, then you also get an option of enter your address manually. So this is also another way of handling that situation, that if you have something where the data is not being passed properly, then you're giving another option to the user. So that is one of the type of test defects as well. Now we are coming to system integration testing. If you see, these are mostly the same type of defects and failures as the component integration testing. The last one, that's different: failure to comply with mandatory security regulations. So because system integration testing is performed after system testing, or maybe in parallel to system testing, so at that time, if we have a system which has to comply with any kind of security regulation, for example, if we are um, doing any kind of penetration testing, or if we are doing any kind of testing which needs to comply with PCI standards, then if there is any card testing involved, or card usage is involved in that system, then we need to ensure that during system integration testing, we also cover all security regulations. And this is the testing where we get to know that if there is any failure, and at that point, then those issues can be reported. Okay. Then the last one is approaches and responsibilities. Any questions so far? Okay, there are no questions, or there is one? No, there is nothing. All right. Okay, so let's first cover that who is responsible for conducting integration testing. So in component testing, we covered that mostly it's developers' job to do component testing. In some cases, maybe testers can also perform component testing, but in that case, the code need to be given to the tester in order to do component testing. The component needs to be provided by the developer to tester. So that's what we covered in component testing. Now coming to integration testing. The component integration testing is done by developers, because that's the time where still developers are coding, they are still developing the system. So with each new component, when they are integrating with the previous components, then they have to perform component integration testing. Similarly, system integration testing is performed by testers, because that is performed either after system testing or during system testing, and system testing itself is performed by testers because that is a validation activity. So I hope this concept is clear as well, that who is performing component integration testing and who is doing the system integration testing. Right. Okay, so now what approaches are used for integration testing? So first of all, let's see component integration testing. So we know in component integration testing, if there are two components, component A and component B, then the focus of this testing should be integration, not the functionality. And why is that? Because functionality for each component individually, we have already tested in component testing. That was supposed to be done in component testing. And that's why thoroughly each component should have been tested in component testing, so that now in integration testing, all we have to focus is between the integration of these components. Over here, let's say if we are doing integration testing and then we come up with any functional issue in one of the component, then it means that we didn't do a good job in the previous test level. And then again, we have to go back and see that what the issue is and fix over there, and then again do integrate it with the defined component, and then perform integration testing again. So that's why the pyramid over here says that component is the most extensive testing which we should be doing, because if we do a good job over here, then our testing effort keeps on reducing as we go up the pyramid. If we, in integration testing, if we focus only on integration, then we'll be able to perform our integration testing quicker. But let's imagine that over here, if we are doing integration testing and we come up with some component functionality issues as well, then it will just waste our time and maybe extend our timeline of that project as well. So it's always a good practice that we cover functionality testing during component testing, and then integration only focus on integration of the components. The same applies to system integration testing as well. That if there are two systems, system A and system B, then we are only focusing on the integration of those systems during system integration testing. We are not focusing on the functionality, because that's something which we have already covered individually when we were testing system A and system B. So we will not be covering that again, because we covered already as part of the this system test, A testing and system B testing. Okay, so there are few more points which we need to remember for integration testing. So the first one is, if integration test and the integration strategy are planned before components or systems are built, those components or systems can be built in the order required for most efficient testing. Okay, what does that mean? That if we have multiple components, let's say component A, B, and C, then we need to test, we have to plan. If we know that these are the components of the system, then we can plan the integration test beforehand. We can define a strategy for integration testing, and then based on that, the development can be done in that order and testing can be done in that order as well. So if component A, B, and C, these are three components which, let's say, are depending on each other. So we will start with component A, and then we will integrate component B, and then we will start working and integrate component C, if that's the order defined. And let's say if we have component A and C, but not component B, then as we covered the concept of stubs and drivers in our last session, then we will use that. So if component B is not there and we need to call it in component A in order to test component A, then we can use the concept of stub, where we can have like a dummy module or a dummy program where we can call a method or a function in order to complete testing of component A. So this is what is covered in the first part, that if we know about the components or systems, then we can plan integration testing before, and this actually helps in efficient testing. The second one is, the greater the scope of integration, the more difficult it becomes to isolate defects to a specific component or system, which may lead to increased risk and additional time for troubleshooting. Okay, what does this mean? In the previous example, we said that if there are 3 components and we are testing component A and B, we are integrating it, we are testing it. Then once we are done and integration testing has passed, then we are adding on component C and then testing it. So what we are doing, we are gradually taking one component, 2 components at one time and then integrating them. The second point is basically saying that, let's say that there are 10 components in a system, and we are trying to integrate them all at the same point. So let's say that we haven't allocated time for this continuous integration, or and we are saying that, okay, when all the components will be ready, then at the end we will merge all of them, and then we will see that what issues are there. But over here, what it's saying, the greater the scope of integration means that if there are more components which we'll be integrating at the same time, then it will be difficult for us to isolate defects. Because let's say that if we have 5 or 6 bugs over there, then it will be difficult for us to identify that these defects are in which component, because we are integrating all the components at the same time. While if we have only 2 components, and if we have any issue, then we know that this defect is caused either by component A and B, and it will be easier and quicker for us to find the defect and fix it. So this in result increase risk and additional time for troubleshooting, because if we don't know that what's the origin, which component is the origin for that bug, then it will require additional time. So this is not a very good approach to integrate all the components in the end. Okay, I think there was a question, so let's take that first. Okay, Vineet is saying this is called as top-down, bottom-up, and sandwich approach, I think. Vineet, you are absolutely correct. So this is something which is covered in the next slide. So yeah, that's absolutely good. You have actually mentioned that before I do. Okay, so the next slide is the strategies that what strategies which we can use for integration testing. So first one is incremental. So incremental is, which we covered earlier, as part of continuous integration, that what we are doing, that we are building small number of components, and then we are testing them one at a time. So, and then gradually we are incrementing it. So this is known as incremental strategy. The other strategy is known as Big Bang. So in that, what we are doing, integrating all components or systems in one single step, which we covered earlier. That if we are not integrating one or 2 or 3 components at one time, and then at the end we are saying that, okay, we'll do it all at the same time, that's a Big Bang approach. A risk analysis of the most complex interfaces can help to focus the integration testing. So let's say that if there is a very small project and it has only 3 components, then maybe Big Bang approach would be fine, because we'll not be having a lot of risk over there, and maybe the interfaces are not very complex. So that's why whenever we have to define an integration strategy, first we need to evaluate the risk. We have to do risk analysis, and that actually helps that which integration strategy would be appropriate for us. Next one, now we're coming to that bottom up and top down integration, as Vineet just mentioned. So when we in incremental testing, integration testing, then we have like further these 2 options as well. We can do bottom up integration testing, which means that each module at lower level is tested with higher modules until all modules are tested. and it use drivers for testing. We will see a diagram, and I think that will make it more clear if the text is not making it very clear. So the second one is top-down integration, which is also known as top-bottom as well. So if you hear about top-bottom approach, then it's nothing different than the top-down one. It's the same thing. So over here, we test the modules at the top level with the ones at lower levels till the entire system is tested. So let's have a look at this diagram. So over here, we have 6 modules. We have module 1, then we have module 2, 3, 4, 5, 6. If we are doing a bottom-up approach, so what we will do, we'll take this module 4 and we will integrate it with module 2. Then when we have done the integration testing, then we will integrate this with module 1. The same over here, module 5 will be integrated with module 2 and then later on with module 1. The same is with this 6, 3, and then 1. So this is bottom up approach. So we are going from bottom to up. And why we said that we can use drivers for that approach, because we are using the bottom-up approach, and we know that the drivers basically are the calling programs, while the stubs are called programs, and those will be used in top-down approach. So in top-down, we will go from top to down. So we will take module 1, we will integrate it with module 2. When the integration is completed, then we will integrate it with module 4. And another workflow would be module 1, module 2, and then module 5. Similarly, module 1, module 3, and module 6. So we have an option of either doing top down or bottom up, or maybe sometime a hybrid approach as well, depending on our system and what's available for integration testing. So in some cases, we can use an hybrid approach as well, which Vineet mentioned as also known as a sandwich approach. Okay, so yeah, that brings us to the end of integration testing. So let's take questions if there are any before we move on to our practice questions. Okay, there are no questions. So either this was a very, okay, there is question. All right, Jatin is asking, when we start system integration testing after system testing? Yes, Jatin, so there are two options. Mostly, I would say it starts after system testing. So let's say that we have two systems and we have system A and system B. So of course, first we will test system A and we will test system B separately, and then we will integrate both of them and we will do system integration testing at that point. That's why we said over here in this slide that if we are doing system integration testing, then we need to focus only on integration, because we have already tested the functionality of system A and system B separately. So yes, we have to perform system integration testing after our system testing, or in few cases, maybe if there are multiple systems and let's say that we have already tested system A and B, we have integrated it already before, and there are few activities which we can do in parallel in terms of system integration testing while we are still testing the functionality of system C. So in few cases, yes, it can be a parallel activity as well, depending on the hierarchy of all the systems involved. But mostly it's system integration testing performed after system testing. So I hope this answer your question. Okay, we have another one. Gaurav is asking, are there any use cases for API and microservice testing for doing integration testing? Okay, so for Gaurav, for APIs, you can say the use cases, we do have in terms of requests. So if when we are doing API testing, so we have multiple requests for that API, and then there can be different functional grouped into different functionalities as well. For example, if we have a payment system, then we can have maybe few APIs for payment section, we can have few APIs for transactions, etc. So we have multiple APIs, and for each API there can be different requests, and each request can have multiple responses. So that's why, yes, we will be having those use cases separately for APIs. And the same applies for microservice testing. Okay, so when we are doing microservice testing, so we will be defining few use cases, or maybe if a developer is doing any testing at that point, then maybe they are just doing the testing without any formal use cases. But for API, we definitely need some formal use cases. So I hope that answers your question. Umair is asking, database testing comes under component testing. Okay, Umair. So yeah, you're right that let's see that what's the scope of database. So we are doing component testing, and each component is tested against the database, which is at the backend. And we are performing all the database checks at that point. So yes, you are right, we will be covering it under component integration testing at that point. And let's see now the system integration testing as well. So in that case, if we are testing a system against a database, then yes, we have tested everything within the functionality of that system whenever it comes to database. And when coming to the system integration testing, database testing, because we are not testing functionality over here, and I'm just thinking of that when we are doing integration testing, if there are still few things which are particularly only for the integration, maybe anything related to architecture, or anything to like related to the communication, the protocols, which is stored or which is required to store in a database, in that case, then yes, it can be part of system integration testing as well. So I don't think we can say that it's only used in component testing, integration testing, though logically it makes more sense to make it part of that. But I think in few exceptional cases, it can be part of system integration testing as well. Okay, so Jatin is saying it's clear. Gaurav is saying yes, thanks. Okay, that's good. Is there any other question? Okay, so Umair is also saying thanks. So that's good that all the questions are clear. Okay, so we can proceed with our practice questions now. So the first one is, stubs and drivers are used in big bang integration. Is it true or false? So take your time and then let me know what do you think is the correct answer. So type your answer in Q&A. Okay, so we have got answers. Let's say what we have got. Umair is saying true. Mira is saying A, which is true. Sahana is saying true. Gaurav is saying yes, which is true. Madhuri is saying true as well. Gaurav, okay. Jatin is saying B, which is false. And then Denmark is saying A, true. Himanshi is saying true. And unfortunately, only Jatin is correct. It's false. So stubs and drivers are only used in incremental integration. And why is that? In Big Bang integration, let's see, let's just go through it again. This means this concept is not clear. Okay, so Big Bang, what are we doing? We are integrating all components or systems in one single step. And why, if we go back to the last session, why we need stub and driver? We need stub and driver that when we are testing components incrementally and we don't have something, maybe one of the component developed, and to fill that gap, we are using a dummy program, which is known stub and driver, depending on like either that program is being called or that's a calling program. So we need it only in the incremental approach. Big Bang, we are integrating all components or system in a single step, means that by that time, all the components and systems are already being developed. So in that case, we don't need stub and driver at all. So I hope that this is clear. Actually, when I was writing this question, I was just thinking that, oh, it's very easy and everyone will be having the correct answer. But I hope that now it's clear, and I'm glad that this one is covered in it. Okay, Vineet has also said false, so yeah, which is correct. So I hope that this is clear now, that why we don't need stub and driver in Big Bang integration. Right, next one is, who is responsible for system integration testing? Take your time and then let me know the answers. Okay, so we have got few answers. Vineet is saying C, but mainly developer. Umair is saying B, which is tester. Denmark is saying tester. Mira is saying both, means both developers and tester. Himanshi is saying B, tester. Sahana, B, tester. And Madhuri, B, tester. And B is the correct answer. So few have, let's just go through the ones who hasn't answered it correctly. Okay, so Vineet, you have answered C, but mainly developer. All right, so over here we are talking about system integration testing, not only integration testing. So we learned that component integration testing is done by the developer. Let's just go back to that slide. So component integration testing is done by developers, because that's at like after component testing. So they are still developing more components. So that will be done by developers. While system integration testing is done by testers, because this is usually done after system testing. And who performs system testing? Testers. So that's why it will be tester, not developer or not both. It will be only tester. So maybe you didn't pay attention on this word system over here and only focused on integration testing. So in the real exam, it can be tricky, and these will be the tricks. Because if you because in during the exam we don't have a lot of time, and maybe due to nervousness as well, we might be just tricked with the question. So it's really, really important, go through the question at least twice and then see the given options. Because later on, if you reflect back, these questions, especially in the foundation level, they are not difficult at all. They can be just a little bit tricky. So please make sure that you are going through the questions at least twice, because if you understand the question and of course you have learned all the concepts, then it will be easier for you to pick the right answer. So I hope that this is clear. I'll just go through and see if there are any more questions on that. Okay, so that brings us to the end of our today's session. So just before the practice question, there was another question by Vineet which I missed, and Vineet asked, database testing comes under functional testing. Yes, Vineet, that's absolutely correct. So when we are performing our functional testing, actually, I would say it comes under system testing. So when we are testing different our validations, then we do perform the database testing, or we are performing testing on different modules or components, then also we perform database testing. Why we I just figured out that why we can't term it only functional testing, because sometimes we also do some non-functional testing as well for databases. Because sometimes let's say that if our database is not able to handle a lot of data, which is only figured out only during non-functional testing, performance testing, then that will then in that case DB testing can be part of non-functional testing as well, if for that system non-functional testing is a requirement. Because for all types of softwares doesn't require performance test. So it depends that whether we need to do that kind of test as well or not. Because sometimes, let's say that we are searching something from database, and then there is like a lot of, it's taking a lot of time to give the that search functionality back. It's taking a lot of time. Then it means also that there is something which either needs to be corrected at the database in the schema end, or maybe at the front end. So yes, we can say that database testing can be part of both functional and non-functional testing. I hope that clarifies. Is there anything else you would like to ask from anything we covered in today's session? Okay, Vineet has asked one other question. One more thing, as a tester, what types of action we can perform on database testing? Because DB testing, there are a number of things. You are absolutely right, Vinny. There is like endless type of testings which can come under DB testing, and that's why it's very important to define all this as part of your when you are analyzing the requirements. So when you are writing your test cases, you need to include all these. Because why we write test cases, this is because so that when we are executing, we know that we have to see these things. Like for example, if you are okay, let's just take this example. Okay, so let's say we are testing this library system. So what we can test, first of all, let's now don't see it from a user interface perspective, see it from database angle, that what will you test in the database. Okay, so when you are logging this library system, you can go back, and of course over there will be a table where it's keeping the log of all the logged in members, that so that if we have to find that, okay, when was the last time a member was logged in, we can see that detail in database. So we can check those kind of things. that, and then if we have any web application where there are lots of loopholes, so you know, when we have some mandatory checks on the front end, it's not necessary then that those checks will be implemented at backend as well. And that's where most of the times the applications are hacked, because they are covered only at the front end. So for example, in an email, if an email is a mandatory field on the front end, but on the back end it's not mandatory, then it is then there can be an issue. A hacker who knows how to enter how to access the database directly can can make use of that as well. Or maybe then we can have a user which is logged into the system without any email address. So these kind of things can happen. So in the schema as well, if the front end email address is a mandatory field, then in the schema as well, we should make sure and go back and see that yes, we have the mandatory field defined as the email one. And the same is with the like the length of characters as well. So at the front end, let's say a phone can have only 11 numeric characters, but in the database it's allowing maybe only 8. So then that's a conflict. So which means that it can't store it at the backend. And then again, if we are registering any user, then we have to go back and see in the database that all the information which the user logged, like let's say first name, last name, date of birth, etc., it has been correctly populated in the database as well. And the same is goes for all the nulls, etc., as well, that where we shouldn't accept any nulls or zeros or blanks. It's aligning in terms of the UI, etc. So these kind of tests we as a tester definitely needs to perform. Otherwise we will be just doing a black box testing, and any user who's using the application can do that black box testing because they don't have access to the database. So that's why a tester needs to do all these kind of checks as well. And if they have access to the schema, at when they are writing the test cases, then their job becomes very easy, because at that time they know that how the tables are interacting with each other, and it makes easier for them to do the traceability with the requirements. And if there is any conflict, they can just go and ask to clarify or maybe redefine that requirement. So I hope that answer your question. So we need this then saying insert, update, delete, select, we mainly know. Yes, we need. So what we do that, of course, we usually mostly we use select statement when we are doing any database testing, because we are checking that whatever we have entered from front end, from UI, that has been stored in the backend as well. But yes, few scenarios where, as I said, that if we insert something in the database which is not compliant with the front end, then yes, we have to do those kind of things in using our insert statement. Or maybe we are updating any record in database using the update statement, or we are deleting any record over there. So what kind of activities we can do and what we can't do. So we have to um, make all these database testing as part of our test design phase. So we need to define all these over there. Okay, the same is the DML command. Yes, all this, yes, we need to do all that. Okay, no, sorry, it's DML command. This is something which the DB, the database administrator, or the person who is doing the database, who is managing the database, they will do that. We don't need to do that. So we need an access to schema, which is defined. And we will usually perform, as you said, all these main activities like select, delete, update, insert, and that also which is necessary as part of our requirement. So we don't have to just unnecessarily just go in the database and perform all these actions on something which is not required or which is not linked to our requirements. So for us, the user requirement would be the main thing, and then we have to think of all the positive and negative scenarios and then come up with the testing which we need to do either from front end or the back end. Okay, so I hope that's clear. So Vineet has also said, we also don't know DQL, TS, TCL. Well, no, we haven't, we don't need to do that as tester. Unless, let's say that there is something, a system is defined or being built in a way where there is a specific requirement that yes, you have to test this command as well. So if it's like specifically asked in a requirement, it's covered in a user story, then maybe you can sit with one of the developer or one of the database people and take their help in testing that, because you as a tester just need to validate that requirement, and otherwise you don't need to do that. Okay, so Vineet is asking, because in banking project, all commands are important. Okay, so Vineet, again, as I said, that it depends that what are your user requirements. Like, I work in a bank and I test banking applications as well. And I have never performed any DDL or TCL. I don't do that. But maybe in one of my user requirements, if it says that yes, you have to make sure that everything which is the output of TCL command, if that's working, if we have a specific requirement, then yes, maybe I will go ahead and I will work with someone who has a knowledge, who has more in-depth knowledge of database. And like usually it depends on the companies as well. Most of the companies, they do have their own database teams as well. So I would expect that this will be covered under that. So either they can cover, so maybe like if we have a user story, so maybe they can cover the testing for that. And being a tester at the end, you can just go and double check that, okay, whether they have tested as per the requirement or not. You can sit with them, they can show you that, yes, I have tested it this way, these are the outputs, and this is how it's working as expected. And then you can sign off that one, or they can sign off as well. It depends that how the hierarchy works in your organization. Okay, so Vineet is saying it's my thinking only. I don't know more about these things, so I ask. Now that's okay, that's completely fine. So I hope it's clear now. Okay, Gaurav is asking how to decide the testing strategy. Okay, so Gaurav, over here, I would like some more elaboration on that. Either you are asking testing strategy specific to integration testing, like integration testing strategy, or are you talking about the testing strategy as whole for the like entire project? That would be the testing strategy of the entire project. Okay, so Gaurav is asking that yes, integration as well as whole project. Okay, so let's see the integration first. So if we have to define, identify that what strategy we should use for integration. So first of all, we need to analyze the project. And this is something which we can do in the beginning if we have all the details, as we learned in the, okay, in that section. Let's go back to this one. Right. Okay, so we have these two main strategies. So what, in terms of testing, how we will be doing the testing, it will be defined, ideally it will be defined as the part of the test strategy of whole, the entire project. And so if okay, let's just take it as a whole project first. So usually test strategies are defined for companies, not projects. So I think in the first session also someone asked about the test plan document and test strategy document. So, and I also shared a link as well to a website for that to clarify that more. So if I find that, I can share that again. But when we talk about test policy and test strategy, that is a company level document. So we never have test strategies for a project. We have test strategies for a company. Like for example, now I'm working as head of QA in my company. So I will be defining the test strategy of my company. And in that strategy, what I will do, I will define that what kind of testing mostly we perform. So I will mention high level. I'm not mentioning any project here. It's about my company, that in this company, we perform functional testing, we perform non-functional testing, and then in further in functional testing and non-functional testing, what kind of testings we perform. Then I will cover that what kind of tool sets we use. So for mobile testing, we use these kind of tools. We do automation for these projects. For automation, we use these tools. For test management system, we use this system. So this is like an overall thing that what kind of test environments we have. So all these things will be part of test strategy of the company. Then later on in the company, we will have multiple projects. So for each project, I will take the things from test strategy and only include those parts in my test plan of the project which applies to that project. So for example, if I take type of testing in strategy, I have mentioned both functional and non-functional testing, but that project doesn't require non-functional testing. So I will not include non-functional testing in that project. So test strategies is a high level document, company level document to tell that in this company, how we perform testing, what kind of testing we perform, and if we, and all those high level. So we will never mention any kind of project. So I will also share the document again, which I'm sure I have tagged in the group as well. But I hope that clarifies your question. Yeah, sure. I will share that again. All right, so Gaurav is saying it clarifies. All right, that's good, Gaurav. Okay, so is there anything else? All right, then we can then end the session. And I hope you enjoyed today's session. And after the session, I will also provide the link of the recording. And by tomorrow morning, hopefully, I'll try my best to also upload the questions as well for this one. Any one of you who hasn't covered any questions for our previous sessions, please make sure you do that and send me, because I also want to, I also keep a track of who is completing which questions, and usually I do ask if someone is quite consistent in answering and then not doing any one or two. So because I want to make sure that you all are putting in effort in attending this webinar and you are serious about taking the ISTQB certification exam. So I want to make sure that you are doing all the assignments and then you are ready to take the exam by the end of this training. Right. Okay. So if there is any other question which maybe you think of later on, then please ask in the group or just send me a message and I'll come back to you then. All right, then take care of yourself and I will see you in the next session on Thursday. Bye.